Now let's look at the present value. So basically, it is the same formula. It's just that we switch. Okay, because present value is the reciprocal of the future value. Okay, so we basically make use of the same formula, except now that it is from the perspective of the principal instead of the future value. Okay, so the formula becomes like this. Okay, let's look at this formula. Okay, just now the FV is at the left equals to the P times the factor. Now we bring the P to the left, but now we call it, instead of calling it principal, we call it the present value. So it is equal now to FV, but since now it is reciprocal, okay, it is divided by 1 plus I to the power of n. Okay, and since we don't want to put this at the bottom, okay, we want to put it at the same level, okay, of the PV here, right? So it becomes FV times 1 plus I to the power of negative n. Okay, negative n, right, which is basically the same. Okay, it is a reciprocal, so it's basically the same as FV divided by 1 plus I to the power of n. Okay, and in your calculator operation later, make sure you don't miss out the negative term when you calculate. Now, as before, I maintains the same. It is still J divided by M, okay, your nominal interest rate divided by frequency of compounding, and N still equals to T times M. Okay. Now let's look at an example. Okay. Now what is the present value, okay, of 1,000 to be received 5 years from today if the interest rate is 5% and with 4 different types of compounding? Okay. Now it is a different perspective. Okay. You are going to receive 1,000 5 years from today, okay, with the different compounding period, and at the interest rate of 5%. How much should you put in today in order to receive or to get that 1,000 5 years from today? Okay. Now with annual compounding, okay, we use a formula. Okay, the future value, right? So it's not future value actually. This should be the PV or the present value. Okay. Okay. Now what we need to do is we need to use the reciprocal of the formula, which is the present value formula, right? So in the first case, let's look at this. -5. Okay. It's 1,000 times 1 plus 0.05 to the power of negative 5, remember? Reciprocal. Okay. So it becomes 783. So in order to get 1,000 in 5 years' time at an interest rate of 5%, okay, for annual compounding, you need to put in $783.53. Okay. For semi-annual, your M now becomes 2. So you plug it in 2 here and 2 here, okay, to the power of them. So it becomes 1,000 multiplied by 1.025 to the power of -10. It becomes 781.20. Notice that the amount is reducing. Okay, why reducing? You need to put a lower amount, okay, if the frequency of compounding increases. Okay. So for quarterly compounding, okay, you need to put in only 780, and for monthly compounding, you only need to put 779. So it is an inverse relationship compared to the future value formula just now, right? Now, let's look at another example. Okay. How much should you deposit today in an account that offers an interest rate of 7.5% compounded monthly, so that your savings will be 10,000 in 7 years? Okay, so in this case, your M, okay, compounded monthly here, M is 12, okay, your T is 7, okay, and your J is 7.5%. Okay, so applying this, right, 10,000 times 1.1 plus 0.075 divided by 12 to the power of negative 7 times 12. Don't miss out the negative there. Okay, so when you want to use your calculator, financial calculator, make sure you find this first, right, which is 0.075 divided by 12, then you plus 1 here, and then to the power of negative 84. Okay, so then only you multiply by 10,000. That should give you 5,925.23. Okay, now this 5,925.23 should be your initial investment. Okay, should be how much you should put in today in order for you to get 10,000 in 7 years time. Okay, at this interest rate, which is 7.5% compounded monthly. Now if we apply similar calculation as the example earlier, now 10,000, how much the money will be accumulated, minus 5,925 will give you $4,074.77. Okay, so this is your return. Okay, how much you will get. Now this 4,074.77, if you divide with the initial investment, that gives you 68.77%. Okay, 0.6877. If you divide by 7, because 7 years, it gives you 9.82%, which is the same annual rate of return as the earlier example. Okay, notice that in the earlier example, the figures are different. Okay, the starting and the end figures are different, but notice that the rate, the interest rate and the compounding period is the same. Okay, and the time period is the same, 7 years. Hence, it gives you similar annual rate of return of 9.82%. Okay, so up until now, I hope you can follow, okay, the workings, okay, and the narration before we move on to the next, okay, subject, which is finding the time period.